How and why did 200-ton steel behemoths almost collide head-on in the pitch-black skies over New York? Currently, 3 terrifying scenarios are under investigation. One possibility is a total radio blackout, where a single critical word was swallowed by the storm, leading a pilot to bank left when they should have banked right. A second scenario suggests that a sudden, violent burst of wind shear, the invisible killer of the skies, slammed into both aircraft, forcing them into the exact same altitude in a matter of seconds. Finally, a third theory focuses on the brain of the operation, a potential catastrophic failure caused by sheer human exhaustion. We're talking about a controller on hour 12 of a back-to-back shift, misreading a single flickering digit on a radar screen. So how exactly did these two massive sky cities almost merge into a fireball? On March 4th, 2026, disaster was avoided by mere feet over the Atlantic. Here is exactly what we know about the recent near miss involving 2 heavy jets inbound to JFK. The incident happened in some of the most congested airspace on the planet, while a massive nor'easter was hammering the East Coast. According to FAA records and leaked radar telemetry, this wasn't just a close call, it was a statistical impossibility. It was an apparent breakdown in the invisible wall that keeps us all safe. One jet was descending through 10,000 feet, the other was climbing out. Flight trackers watched in horror as the 2 icons on their screens literally merged into one, indicating a certain mid-air collision. But then, something miraculous happened. The icons separated. One aircraft executed a desperate high-G bank, while the other plummeted into a controlled dive. When the radio transcript finally emerged, the panic in the cockpit was chilling. But how does a nightmare like this actually happen in the most advanced aviation system in the world? When near misses occur between these flying skyscrapers, it usually comes down to one of 3 terrifying scenarios. When we look at the data, the scene on the radar screen tells a story that no pilot ever wants to hear. Imagine a world made of matte black paper and neon green ink. In this stylized documentary, we are watching a stop-motion nightmare unfold. 2 tiny glowing paper cutouts representing 200 tons of pressurized aluminum and human lives are pulsing across the dark green. These aren't just dots. These are Flight Delta 1092 and United 445, and they are currently on a trajectory that defies every rule of physics and safety in the FAA handbook. At exactly 2:14 a.m., the technical reality of the situation becomes shocking. We are talking about a total loss of separation. In the world of air traffic control, there is a protective bubble around every aircraft. Usually, that's 5 miles of horizontal space and 1,000 feet of vertical distance. But on this night, that bubble didn't just pop, it vanished. Flight trackers watched as the altitude readouts began to fluctuate wildly in the heart of a violent nor'easter. United was holding at flight level 320. Delta, caught in a massive downdraft, began to drift. Within seconds, that drift became a plunge. The numbers are terrifying. Delta 1092 was traveling at a ground speed of 540 miles per hour. United 445 was closing in at 510. That is a combined closure rate of over 1,000 miles per hour. At that speed, these aircraft are covering the length of a football field every fraction of a second. The radar telemetry shows the vertical gap closing from 1,000 feet to 500, then 300, until finally they were separated by a mere 100 feet. To put that in perspective, the tail fin of a Boeing 777 is over 60 feet tall. They weren't just flying near each other, they were trading paint in the clouds. Inside the cockpits, the atmosphere went from routine to lethal in a heartbeat. The TCAS, the Traffic Collision Avoidance System, is the final line of defense, and it doesn't whisper. It screams. In the United cockpit, the synthetic voice bellowed, "Traffic, traffic." Seconds later, the life-saving command, "Clim now." Simultaneously in the Delta cockpit, the computer ordered a desperate dive. The pilots have no time to check with the ground. They have no time to discuss. They have zero margin for error. They must react to the machines or they will die. But while the cockpits were a symphony of alarms, the Thopdil Kin, the tower at JFK, was gripped by a chilling, paralyzing silence. For a controller, this is the ultimate horror. You see the icons merge on your screen. You see the data blocks overlap until they become a single, indistinguishable mess of neon green. At that moment, you are no longer a controller. You are a witness. If you speak, if you give a conflicting command over the radio, you might actually steer them into a fatal embrace. The silence in that room wasn't just quiet. It was a heavy, suffocating weight. Every breath was held as the controllers watched the radar sweep, waiting to see if one icon would emerge from the other, or if they would both simply vanish into the static. If those 2 aircraft had collided, the result would have been the single largest aviation disaster of the decade. We aren't just talking about a crash, we are talking about a mid-air disintegration. 2 wide-body jets, loaded with thousands of gallons of jet fuel, colliding at a combined speed of 1,500 feet per second. The debris field wouldn't have been a crash site. there would have been a rain of fire covering 3 different New Jersey counties. Hundreds of lives in the air, and potentially hundreds more on the ground, were balanced on the edge of a razor. So how does a nightmare like this happen in a system that is supposedly fail-safe? How do 2 flying cities end up sharing the exact same square inch of airspace? When you look at the surviving data and the shocking telemetry from that night, it becomes clear that it wasn't just one mistake. It was a perfect storm of technical glitches and human limits. When mid-air near misses occur in these congested corridors, it usually comes down to one of those 3 terrifying scenarios we discussed. But to truly understand why we were 100 feet away from a national tragedy, we have to look deeper into the invisible architecture of our skies. We have to understand why zero margin isn't just a safety goal. It's the only thing keeping the world from falling out of the sky. The real reason behind all this might be hidden in the very tools we use to stay safe. Because in this dance of shadows, the line between a routine landing and a catastrophic headline is thinner than the paper our radar screens are made of. When you realize the complexity of what's happening behind those screens, you start to see that the invisible war for our skies is fought every single second with people you will never meet, using logic that most of us will never understand. So, how do they do it? How do they vector these giants through a needle's eye? It all comes down to the terrifying precision of the zero-margin world.
But how does a tragedy like this actually get avoided? When these massive jets dance on the edge of a blade.
Survival isn't about luck. It's about a process so complex and high stakes that most of us can't even fathom it. It's called vectoring. To the average person, a radar screen looks like a chaotic mess of dots and lines. But to the brain in the tower, it's a 3-dimensional game of Tetris played with 200-ton machines moving at the speed of sound. The complexity is staggering. Imagine trying to organize 100 speeding bullets in a pitch-black room, ensuring they never cross paths, all while a storm is trying to blow them off course. This is the zero-margin world. In the tower, the margin of error is absolute zero. If a controller miscalculates a turn by just a few degrees, or if their eyes linger on the wrong data block for 1 second too long, the result isn't a fender bender. It's a national headline. They often say that in this room, a move of just 1 millimeter on the radar screen translates to a full kilometer of separation in the actual sky. The pressure is suffocating, yet the execution must be flawless. To keep these airborne armadas moving safely, controllers must vector aircraft through invisible corridors. They are essentially sewing the sky. One plane is told to climb to flight level 350, another is ordered to turn to heading 270, and a third is told to reduce speed by 20 knots. It is a symphony of commands issued in a specialized language where every syllable counts. There is no room for small talk. There is only the mission. They are effectively building a floating bridge of data, structure made of radio waves and human intuition that keeps the world from falling out of the sky. But why is this unglamorous task considered the lifeblood of our modern world? Because without them, the operation of global society simply cannot happen. We often think of pilots as the stars of the show, but air traffic controllers are the invisible lifeblood of the global economy. Every year, over 4 billion passengers and $12 trillion worth of cargo move through the air. From the life-saving medicine in the belly of a cargo jet to the microchips powering your phone, everything depends on the smooth throughput of our airspace. If the ATC system were to grind to a halt for just 60 minutes, the chain reaction would be catastrophic. Supply chains would snap. Hospitals would run out of critical supplies. The global economy would bleed billions in hours. They are the silent gatekeepers of our prosperity. Yet, they remain largely anonymous. They are the unglamorous sentinels who only make the news when things go wrong, but their success is measured by the millions of times every day that nothing happens at all. During that nor'easter at JFK, this invisible lifeblood was under the ultimate test. As the wind shear ripped through the approach corridors, the controllers were performing what we call the dance of shadows. This is when they must coordinate dozens of aircraft simultaneously in zero visibility conditions. Their crews are aware that their unglamorous task could mean the difference between triumph and catastrophe. They aren't just reading dots, they are managing the lives of thousands of people who are currently sipping coffee or sleeping in their seats, completely unaware that their lives depend on a person in a dark room miles away. Stealth is a shield for bombers, but for a commercial jet, transparency is the shield. The controllers emit a cacophony of electronic noise and commands, masking the movements of the fleet and guiding them through the gaps in the storm. Meanwhile, in underground command centers, senior analysts watch real-time feeds, ready to redirect entire flows of traffic. If a single radar flickering to life indicates a new threat, this is the strategic shift that rewrites the tactical playbook of the sky. When you see the actual distance these jets have to navigate, often bypassing hostile weather and navigating around the airspace of neighboring sectors, you realize it's a complicated process. They have to navigate or entirely bypass the dead zone, where radar coverage is thin. Defense analysts estimate that the actual coordination required to land a single jet during a storm is equal to thousands of individual calculations. Although these routes may The strategy of the sky is built in waves. The first wave is the long-range flow control, managing the arrival of jets from across the ocean. The second wave is the terminal environment, where planes are stacked in holding patterns, waiting for their turn to drop. And finally, the third wave. The final approach, the tip of the spear, where the plane is handed over to the tower for landing. Each wave is heavily laden with data and precision. While the pilots hit the switches in the cockpit, the controllers hunt for the safe paths. Their ADS-B radars scan the ground and the air, looking for any deviation. Once a plane is Winchester, out of fuel, or low on time, it must land. There is no second chance. They retreat to those landing tracks established in Phase 1, taking on the responsibility of landing safely before turning back for a second sortie the next day. The real reason behind all this, it's not just about moving metal. It's about the interpretation of data. It's about the human brain standing between us and the chaos of the clouds. When you realize that your personal safety is balanced on this invisible architecture, the way you look at the sky changes. This data doesn't just result in a safe landing, it affects the security of our world and the stability of our lives. Once you understand the dance of shadows, you see that we are all passengers on a floating bridge of information. The next time you feel that gentle thud of the wheels hitting the runway, remember that it wasn't just a pilot who brought you home. It was a person behind a screen who saw the path through the dark when no one else could. Ultimately, the story of the near miss at JFK isn't a story about a failure. It's a story about why the system actually works. It proves that despite our modern obsession with automation and machine logic, the ultimate safeguard of our skies remains the human element. High-tech sensors and advanced collision alarms are just tools. They are the shield. But the air traffic controller is the hand that holds. Safety isn't a passive state of being. It is an active, exhausting achievement, fought for in the silence of dark rooms by professionals whose names you will never know. The next time you're sitting in a window seat, looking out at the vast, empty expanse of the clouds, realize that you aren't just flying on a plane. You're being carried across an invisible web of data and human intuition. Every smooth landing you've ever had, every routine flight that felt completely uneventful, that was a silent triumph. It was a victory won by a controller who spotted a conflict 10 minutes before it could even manifest and made the one small, decisive move that kept you safe. That boring flight is their greatest masterpiece. So we look back at that night in March 2026, not with lingering fear, but with a renewed sense of gratitude. We were 100 feet from a national tragedy, but we were miles deep in professional excellence. The invisible lifeblood of our global infrastructure held firm. The dance of shadows reached its finale, and every passenger went home to their families. To the men and women in the towers, the night watchmen who keep our world moving while the rest of us sleep, thank you for the silence, thank you for the routine, and thank you for guarding our skies.